Hi students, welcome in chemistry classes. I am Priyanka Jain and today here we are with a new reaction mechanism, that is Tsuji Trost reaction mechanism. That is quite important for CSIR NET GAT exam. Okay, for all entrance exam this reaction is equally important, and here I have given you different examples that I will tell you in my this video. Okay, so if you don't know about this reaction or if you cannot do these questions, then my opinion is this, that you should watch this video till end, because beside these examples we will see several other examples. Okay, so if you don't know, then you can watch complete video lecture, or if you can do these problems, please pause the video and see these questions. If you can solve these yourself, then you does not need to see this video. Okay, so let's start our lecture. Firstly, we will have to understand what is Tsuji Trost reaction. Then we will see its mechanism, different type of patterns which are asked with stereochemistry. Okay, and then we will solve the examples. So firstly, understand what is Tsuji Trost reaction. Suppose you have given such type of system. Suppose you have given a system like this. It means this is allylic system and there is an X group. X is a leaving group. X may be OCOR, any living group. It may be OCOR, it may be OCHR, CHNHR, it may be Cl, it may be NO2, it may be OH, it may be SO2PH, any type of living group. If it is present at the allylic position and it is treated with palladium catalyst, palladium in zero oxidation state catalyst, in the presence of a nucleophile, then what will happen? This leaving group will leave out and at this position you are getting the nucleophile. It means there is the substitution of this X group with this nucleophile. Okay. Suppose we are taking in this manner X and here is R. Then this in the presence of palladium catalyst and nucleophile will change into this type of product. Here in this reaction, in this reaction you are getting this type of product or you may get this type of product. Both are equivalent. Okay, you can get either this or either this, but in this type of reaction, in the second reaction, you will get this type of product. Okay, and one important thing about this reaction is that this nucleophile is attached or substituted with retention of configuration. Why? Because actually there is happening two SN2 reactions. Okay, and SN2 happens with inversion of configuration, but there are two SN2 reactions. One time there happens inversion and second time again we are getting the same configuration. So there is the retention of configuration. This we will see when we are watching the stereochemistry. Okay, now see what is happening in this reaction. Suppose you have given this type of compound. This is allylic position. There is any group R1. Okay, when it is treated with palladium catalyst in zero state, this palladium catalyst will be present like this. Okay, this is zero valent palladium. This react with this. Okay, and we are getting R1X. At this position, this get in this manner. This reaction is called oxidative addition reaction that you have studied in the organometallics. Okay, and the next step, what will happen? See here, this is the allylic system and it can be changed like this. Okay, this palladium is attached to this group in this manner by three atoms, 1, 2 and 3. Okay, this get attached in this manner and we are getting a allyl complex, pi allyl complex. Okay, this is ligand and this is X. Now what will happen? This palladium complex will undergo the ligand exchange. It means this X group will get removed and here we are getting L group. These two are the pi allyl complexes. Okay. Now this pi allyl complex will react with the nucleophile. Now see here, in this situation, the nucleophile can attack only from this position. Okay. This is the position where nucleophile can attack. But if there is no R group, then it can attack. If there will be no R group, suppose if there is no R group, then it can attack either from this position or from this position. But in this case, there is sterical hindrance like this. So it is attacking from this one position. Okay. So what we are getting here, this is our palladium complex. Okay. And at this position, we are getting nucleophile. Now our palladium complex will get removed, and we are getting R1, and at this position we are getting nucleophile. In this manner you can see that this compound is changed to this compound. It means this X group is now changed by this nucleophile because there is 2 times the SN2 reaction mechanism. Okay. Now see here, this was a general reaction, but Tsuji Trost reaction can be done in different ways. It can be done in the cyclic systems. Okay, so we will have to see all the systems because in question paper you will not given the normal type of questions. Okay, you can have given a cyclic system, or you may have given any epoxide in which you have to do the Tsuji Trost section. Okay, or you may have given intramolecular type of the reaction. So these systems you will have to consider. Okay, so firstly I am giving you the cyclic system. What is happening in the cyclic system? See here. In this question you can see whole the stereochemistry. Okay, you will understand how to do the question with stereochemistry. So this is your cyclic system and this is PDL2. Okay, this is our palladium complex. Now see here, this is the allylic position where the X is attached. Okay, now this palladium complex will attack on this pi bond. Okay, so we are getting a pi allyl complex at this position. See here, this is our X that is above the plane. So this palladium complex will attach below the plane because always the reagent go at the site where there is space. Okay, so this will go at the below the plane side. Okay, now what will happen? This complex will change in this manner. Okay, in this manner. This is PDL2 that is attached here by the 3 atoms. Okay, now you are getting this type of pi allyl complex. Okay, then there will be the attack of nucleophile. Now the nucleophile can attack from this side. Either it can attack from this side or it can attack from this side. Both the sides are equivalent, so it can attack from any of the side. But if you have given unsymmetrical system, okay, then the nucleophile will attack from the less hindered side. In this case, it can attack from any of the side. Suppose it is attacking from above the side. Okay, so we are getting nucleophile here, and here this is palladium complex. See here, this nucleophile has attacked from above the plane side. Why? Because our palladium complex is formed below the plane. So we are getting nucleophile above the plane. Okay, then this will change to this complex. Okay, so this will be your final product. I think you get understand all the concept. Now see one question from CSIR NET. You have given this compound and this is our nucleophile. Okay, so what will happen? See here, this palladium complex will attack at this side and it will attack from less in that side. It means it will attack from below the plane because our epoxide is above the plane. So this bond will break up. Okay, this bond will break up in this manner. So what you are getting at this position, you are getting PDL2. Okay, and here this is our O minus. Now this complex will change to pi allyl complex. Okay, so you are getting this is O minus, and here at this side you are getting in this manner. This is your palladium complex. Okay, this will be. Now this O minus will abstract the H plus from here. Okay, this is your nucleophile, and from this position this is the hydrogen that it can abstract. Okay, from this position it is abstracting the hydrogen. Okay, so we are getting here at this position OH. Okay, and at this position this is your complex. Now this nucleophile, now your nucleophile will be, suppose these are RR groups. Okay, this is R group, this is R group, and this is CH2 minus. Okay, so this will attack either from this side or it can attack from this side. Which side? will be appropriate? Can you tell me which side will be appropriate? See here, on this side, if you are watching this side, at this side there is hydrogen OH group. Okay, so this is sterically hindered. Okay, so this nucleophile will attack from this position. Okay, so it will attack from the less hindered side. Means to say, what will happen? See here, this is our OH group. Okay, and at this position you are getting your product, your nucleophile. Okay, so here you will have to write CH2, this is COOCH3, this is COOCH3. Okay, and here will be your double bond, and this group will be above the plane because our nucleophile will attack from the less hindered side. It means above the plane. Always remember, the side of the nucleophile and the side of the leaving group will be same. Okay, both will be at the same side because we are getting the product with retention of configuration. Okay, now see the next example. See here, we are taking an example from GATE 2023's question paper. This is the compound that is given to you. Okay, and it is treated with PPS3 whole 4. Okay, and you have asked the product formed. Now see, you can see if you have given an allylic compound. See here, this is the allylic position at which there is OAC group present. It means a leaving group is present at the allylic position. Okay, so what will be your first step? Your first step will be the addition of this palladium complex at this position. Okay, so make it at this position. You will have to attach this palladium complex PDL2. Now this leaving group will remove and you are getting here a pi allyl complex at this position like this, okay, with positive charge. Now the question will be from where the nucleophile will attack and what is the nucleophile. See here, this is an example of intramolecular Tsuji Trost reaction because you can see there is a ring. Okay, you can see here this is a ring and this is a side chain. Okay, and this side chain, you can see this is the side chain and it can fuse here. Okay, so from where it will fuse, from this atom it can attack here. This will act as inbuilt nucleophile. Okay, so you will get here attack. Okay, now you can see that this group is above the plane. This side chain is above the plane. See here. So it will attack from the above the plane side. It means this attack will be above the plane. And this will be your group. Okay. There will be a positive charge. Now this positive charge will come like this. And you will get a product like this. At this position there will be a double bond. This will be R group. So this will be the stereochemistry of the final product. You can see the question paper. Option number A is the right answer. Okay. So in this way you have to do this question. This is an example of intramolecular Tsuji Trost reaction. Let's see the next example of the intramolecular Tsuji Trost reaction. See here, you have given this question. Okay. Now you can see here, there is a group at the allylic position. This is the leaving group and this is the palladium catalyst that is given to you. Okay. So there may be a reaction that is Tsuji Trost reaction. But now the question is, where is the nucleophile? See here, this is the nucleophile. This is acting as the nucleophile. This is the side chain. Okay, this can attack. So how this reaction will happen? In the first step, there will be the attack. Okay, at this position, at this double bond, there will be the palladium complex formed, and this complex will be formed below the plane. Okay, okay. Then in the next step, it will form a pi allyl complex like this. Okay, then in the next step, see here, this is the R group. I am writing here R group. Okay, this is the R group. This is your NH and this is pH. Now this can attack. Okay, this will attack at this side. Okay, so we are getting in this manner your product. Okay, this ring is above the plane and there will be 2 hydrogens below the plane. Okay, so this type of question may be asked in the question paper. This is an example that I have taken from Claydon, but they may ask this example because several questions for Corethus and Claydon are asked every year. So this question may be asked, so it is quite important. Okay, now see the next question. One more question. See here. Suppose you have given this type of compound, okay, and it is treated with PD, PPS3 whole 4. Then what you have to do? See here. This is your double bond, so this will be your allylic position, okay, and this is OSE group. So you have to do the reaction in the same manner. Here you have to make a palladium complex, okay, and this is your OSE group. Now in the next step, there will be the formation of in this manner. See here, this is OSE. Now this OSE will get removed. Okay, this will get removed, and at this position you are getting a pi allyl complex. Okay, now in the next step, a new nucleophile. Say the new nucleophile may be anyone. It is RNS2 here. Okay, this may attack. So you are getting NHR. Okay, and your double bond will come here. Okay, so this will be your product. Okay, so now I am writing here RNS2 that I forgot to write. Okay, so this will be your reaction. Now see one more question from CSIR NET November 2020's question paper. Now see this question. Question is somewhat tricky. See here. In the following transformation, the enantiomerically pure lactone A provides. We have given this lactone, and in the presence of this palladium catalyst and this nucleophile, this is converted to P. It means we have given the answer, we have given the product. But what is asked to us that we are getting one number equimolar amount of syn and anti-diastereomers of B which are racemic, or equimolar amount of syn and anti-diastereomers of B which are enantiomerically pure. C option is given only syn diastereomer is formed, that is racemic, and D option is given only anti-diastereomer is formed, which is enantiomerically pure. It means we should know the stereochemistry of this product B. Okay, we should have idea of this stereochemistry. So first of all, I'll understand what are the diastereomers, syn and anti forms of this. So see here, this compound can be written in this form. Okay, this can be written like this if this is above the plane. This group is above the plane and this group is also above the plane. This means this is syn. Okay, or it may be in this manner. This is above the plane and this is below the plane. Then this will be called anti-isomer. Now each of them can have their mirror images. It means they can have enantiomers. Both of them can have enantiomers. So first of all, we have to find out that whether we are getting this product or we are getting this product or we are getting both. Okay. So we will have to understand this concept. So see here, you have given this type of compound. This is actually a lactone that is given to you. Okay, this is a lactone. There is a double bond and there is this type of bridge. This bridge is below the plane. You can understand this whole ring is above the plane. It means this is in this manner. This is above the plane. Okay, this side is above the plane. And that portion that you have seen here in dash position, that is below the plane. Okay, now it is treated with PdL2. Okay, this is our palladium complex. So this palladium will attack at this position. Okay, now you can see that this ring is above the plane, so it will attack from below the plane side. It means this will attack on this side like this. This is our PdL2. Okay, and this is our bridge. Okay, now in the next step, what will happen? This will form pi complex. So I am making it here. Okay, this will be your palladium complex. Okay, there will be a positive charge. Now, when this palladium complex is formed, this bond will open like this. This is oxygen in the ring, so this can open. Okay, so when this will open, O will move here Okay, so you are getting O minus. Okay, and at this position there is this palladium complex PdL2, positive charge. Now there is a time of attack of nucleophile. Okay, the nucleophile is R, and here minus charge. This is our nucleophile. Now from where it will attack, it can attack either from this side or can attack from this side. Okay, these are the two situations from where it can attack. Now we will have to firstly make the ring. See here, this is 1, 2, 3, 4, 5 and 6. 6-membered ring. So I have to make a 6-membered ring in this manner. Okay, and this is suppose 1 position and this is 6 position. 2, 3, 4, 5. Okay, now there will be a double bond here. Okay, and 1 position. This is your group. Okay, and at the 5th position, if we are attacking this group at the 5th position, what you are getting at this position, you are getting in this manner your R group. This nucleophile you are getting here. Okay, this is above the plane. And second condition is that you can get in this manner. This is your group. Okay, and at the 3rd position you are getting your nucleophile like this. Now your bond will be at this position. Okay, now you can see here these two. See here, these are the syn isomers. Okay, so you are getting the syn isomers only. Okay, you are getting syn diastereomers. Okay, but you can see these two are the mirror images. It means you are getting two types of the enantiomers. Both are optically active. You are getting two isomers. Okay, so this is a racemic mixture. Okay, this is a racemic mixture of syn isomers, syn diastereomers, and that was given to you in the option number C. So your option number C is the right answer. I think you got clear all the concept. Okay, so in this way you have to do this question, and all the questions are now clear in your mind. Okay, I hope this video will be very much useful for us, and if you want more such type of videos, then you can comment me. Meet you in the next video with some more interesting topics. Thank you.